Today I'm going to do the prime factors kata. So I'm just going to start my tests and describe a prime factor calculator. The first thing we should test is if it calculates the prime factors of 1, which is just an empty vector. And this fails because we haven't even created a prime factors function. So I'm going to do that and just return an empty vector. The next test we should do is check if it calculates the prime factors of 4, which should just be 2. This also fails because we're just returning an empty vector. So I'm just going to name the parameter and check if n is 1, return an empty vector, otherwise return a vector with 2. The next test we should do is check if it calculates the prime factors of 6, which is 2 and 3, and this fails. So I'm just going to add another if statement nested inside the other one, and if n is 4, return a vector with 2, otherwise return a vector with 2 and 3. And we can clean this up a little bit because it's nested ifs, so we can just turn it into a cond, and so it'll be a little cleaner. I'm also going to rearrange the conditions of the cond to make it a little bit more readable as well. And we can see a pattern here, which is that all the numbers in the output array divide n evenly, or with a remainder of 0. So to generalize this, I'll just create a loop that checks if each number from 2 to n divides n with a remainder of 0, and add those numbers to a list. And everything still passes, so we're good. We can also convert these nested ifs into a cond like before. That still passes. And then another thing we can do is extract the 0 mod nm part to be a factor of function. So we're really checking if m is a factor of n. But we can even do more, and that is to use the filter function, because that's essentially what we're doing. We're just filtering the numbers that are factors of n in the range 2 to n. And everything still passes. So we can go on to our next test, which is to check if it calculates the prime factors of 8, which should be just 2. But we get 2 and 4, so it's pretty evident that we need to also start filtering the prime factors and not just the factors. So I'm going to comment out that test and create a context where I test a prime checker. And the first thing that it should do is check if 1 is prime, which it shouldn't be. This fails because we haven't created a prime function, so I'm just going to do that and return false. Next, we should check if 2 is prime, which it is, so that should return true. It doesn't, so I'm going to name the parameter n and just check if n is 2. And then the next test we can do is check if 3 is prime, which it should be. That fails, so I'm just going to change the function to check if n is not equal to 1. Next, I'm going to check if 4 is prime, which it is not, but it says it is. So what I'm going to do is I'm going to check if n is less than 4, then do what we did before, otherwise just return false. And then the next test we can do is to check if 5 is prime, which it is. That fails, so I'm just going to change the false to check if 2 is not a factor of n. Then it passes. And the next test I'm going to do is check if 9 is prime, which it is not. But our program says it is, so I'm just going to also check if 3 is a factor of n, and it shouldn't be for it to be prime. So we can sort of see a pattern here. We're just going to keep incrementing this number 2, 3, and so I'm just going to put that into an every function and check that every number from 2 to n is not a factor of n. And that makes our test pass. And so now that we have a working prime checker, we can go back to our failing test, uncomment it. It'll still fail because we haven't changed the prime factors function, but it's simple to just add a check if the number in the range is prime or not, and that makes it pass. So another thing we can do is extract this check into a prime factor of function, which will make it more readable. And everything still passes. And you may notice we haven't checked any prime numbers in this prime factors checker, so that'll be the next thing I do. I'll calculate the prime factors of 2, which is just 2, and that fails, but the simple solution to that is just to make the range inclusive, and that'll make it pass. So for good measure, should check some more numbers. I'll check 3, 10, and 11. All the tests pass, so that's it, and it concludes the prime factor kata.